Hey everyone, here's our math problem for today. This is a math Olympiad question from South Africa. Here's the problem. X squared minus y squared equals 24 and x times y is equal to 35. Find the value of x plus y over the set of complex numbers. You can pause the video and see if you can answer this math Olympiad question. Now let's solve this problem together. There are two approaches to solve this problem. One is to go directly to the value of x plus y, and the other one is to find first the individual values of x and y and then get their sum. The first approach would need a lot of creativity, while the second approach would need a lot of computation, because you will find out that there are many possible values for x and y, and you are going to find the right combination that can satisfy these two conditions. So let's begin first with the first approach. Go directly to the sum of x plus y. We notice here that x squared minus y squared is a difference of two squares, so let's factor that out. The product of the quantity x plus y and the quantity x minus y. Next, our target is this product xy equals 35, and there's no xy here. So what we can do is we can square both sides of the equation like this. Now, the left side may look complicated, but actually, think of the first factor as one variable and the second quantity x minus y as another variable, and its form looks like this. You have the product of m times n raised to the second. So here our m is x plus y, our n is x minus y. And this is the power of a product that is equal to this right side form, m squared times n squared. So this can now be simplified this way. The first factor raised to the second times the second factor raised to the same exponent. The right side is just copied. Now let's expand these two squares of binomials. So the square of the sum of x plus y is this part. The square of the difference of x and y is this part. The right side is just copied. Notice now that we have here xy and we have here xy. And we know that x times y is equal to 35. So we can replace this xy by 35, and here is the result. 2 times 35 equals 70. Negative 2 times 35 is negative 70. All the rest are just copied. You have here x squared and y squared here. You have here x squared and y squared. And you have plus 70 and minus 70. We can rearrange the order this way, so that you can now think of this as one variable. Think of this as another quantity. Notice that this part here is just the same as this, and you have here minus 70. So that is exactly this form, a plus b, where a is x squared plus y squared, b is 70, and so the other part would be a minus b, because x squared plus y squared is a, and 70 is b, we copy the minus sign. And again, this is a special product that is equal to the difference of two squares. This part here, therefore, cannot be written this way. Our a is x squared plus y squared, which is now this part. Then we copy the exponent, which is now this exponent. We copy the minus sign, and our b is 70, and we square to get this exponent too. Let's simplify this further. You have here variables, and you have this constant. We can add plus 70 squared to both sides so that all the constants are at the right side. Now compute 24 squared and 70 squared. That is 576 and 4,900 respectively. Get the sum, and that is 5,476. We just copy the left side. Now in here, we can eliminate this exponent by extracting the square root of both sides. So this is plus or minus. Simplifying, we now have this base, x squared plus y squared equals plus or minus 74. So we now have the value of x squared plus y squared, but our goal is to find x plus y. So let's recall another identity. The square of a binomial is equal to x squared plus 2xy plus y squared. We can arrange this first this way. You have this 2xy, and we copy x squared and y squared. We know that this 2 times xy is 2 times 35, which is 70, and we know that x squared plus y squared is this value here. That's why we have this 74. And we now have here x plus y as the base, which is what we want to find. So if we can eliminate this exponent 2 by taking the square root of both sides, then we already have the value of x plus y. So let's do that. Since we have here plus or minus, This first part is for 70 plus 74, and the second part is for 70 minus 74, which is negative 4. Then in here, we take the square root of both sides to get plus or minus 12 for the value of x plus y. In here, we take the square root of both sides, and we have x plus y is equal to plus or minus 2i. Because the plus or minus square root of negative 4 is plus or minus 2i. So we now have the values for x plus y. And those values are plus or minus 12 and plus or minus 2i. So we have 4 solutions all in all. Now, if we are going to go to the second approach, which is to find first the individual values for x and y, and then come up with the sum of x plus y later on, here is the procedure that you are going to use. We note first that since x times y equals 35, it follows that y is equal to 35 over x, provided x is not equal to 0. And we are going to use substitution in order to solve this problem. So we know that y is equal to 35 over x, so we can replace this y by 35 over x, like this. Then we apply here the power of a quotient that is equivalent to 35 squared over x squared. We have here a denominator of x squared, so we can eliminate that by multiplying each of the terms by the LCD, which is also x squared. This becomes a 4th degree equation, x to the 4th, minus this x squared divided by x squared is 1, so we have 35 squared, and we copy the minus sign, equals 24x squared. So this is now the equation that we are going to solve, written in the standard form. But this is a quartic polynomial equation. One way of solving this is to use variable substitution. We let this x squared be equal a certain variable a, which means a squared is equal to x to the 4th. That way, we can turn this 4th degree equation into a quadratic equation. X to the 4th is now a squared, this x squared becomes a, and 35 squared is 1225. So how do we solve this quadratic equation? We can use quadratic formula or factoring method or completing the square. Using factoring method, we use the tic-tac-toe method. Factors of a squared are a times a. Now factors of 1225 would be so many combinations, but the combination that will give us a middle term of negative 24a when added would be negative 49 times 25. To check, a times 25 is 25a, a times negative 49 is negative 49a. When added, this gives us the middle term, negative 24a. It takes a lot of trial and error before you can arrive at these two combinations. So this means that the factors of this quadratic equation are a minus 9 and a plus 25. So from here, we can now solve for a. From the zero product property, a minus 49 equals 0, and the other factor a plus 25 equals 0. This gives us a equals 49 and a equals negative 25. But what is the value of a? We said that a is equal to x squared, and from here, we will now be able to solve for the value of x. So in here, this means that x squared equals 49, and solving for x, take the square root of both sides to get x is equal to plus or minus 7. So we now have the value for x, and we know that the value of y is 35 over x. So we can compute for the value of y. Y is 35 over this positive 7, and y is equal to 35 divided by this other x, which is negative 7. That gives us negative 5. For the second equation, this will give us a negative square root, which is a complex number. But this is okay because we are solving this over the set of complex numbers. So solving for x, x is plus or minus 5i. Again, we know that y is 35 over x, so we can compute for y. Y is 35 over the positive 5i, and y is equal to 35 over negative 5i. This still can be simplified this way. We multiply both the numerator and the denominator by I so that we can eliminate this imaginary unit I in the denominator. And the result of this would be the numerator times the numerator is 35i. The denominator is 5 times I, but I times I, or I squared, is negative 1. And so this gives us 35 divided by negative 5 is negative 7. Then we copy the I. Lastly, 35 divided by negative 5i can be simplified this way. We multiply both the numerator and the denominator by I, then multiply the numerators and multiply the denominators. I times I is I squared or negative 1. We copy this negative 5. Then negative 5 times negative 1 is positive 5. So 35 divided by 5 is 7, copy I, to have y equals 7i. And we now have these different possible combinations for the values of x and y. But not all of these are solutions to this given system of equation, because it's possible we introduce extraneous roots when we square the equation. To check, we can use this product x times y equals 35 as our way of checking which among these possible answers are the correct one. So we can check positive 7 for x, y is positive 5. If you multiply 7 times 5, that is 35, which is correct. If you substitute that here, you will still get 24. The next combination would be negative 7 times negative 5, because negative 7 times negative 5 is positive 35. And when you substitute these values also for x and y to x squared minus y squared equals 24, you get a correct answer. On the other hand, if you take one positive and one negative, that will give you negative 35 for the product, and therefore, those are extra roots. For the right side, we can have positive 5i and negative 7i, because 5i times negative 7i is equal to negative 35i squared, but I squared is negative 1, so negative 35 times negative 1 is positive 35. And lastly, x here is negative 5i, and we combine that with this positive 7i, because when we multiply, negative 5i times positive 7i is equal to negative 35i squared, which when simplified is also equal to this 35. All the other combinations will not satisfy this given two equations. So, now that we know what are the individual values for x and y, the next step is to solve now our problem. What is the sum of x plus y? So 7 plus 5 is 12. Negative 7 plus negative 5 is negative 12. 5i plus negative 7i is negative 2i. And negative 5i plus 7i is positive 2i. And if we compare this with our previous result, we said that x plus y is plus or minus 12, which are now these two values. You have positive 12 and negative 12. That is this plus or minus 12. Then the other solutions are plus or minus 2i. So positive 2i is this part, and negative 2i is this part. Notice that we arrive at our desired answers without going through these preliminary steps. And the first solution was direct to the point. The second solution, go through finding the individual values of x and y, although we are not asked what are those individual values. We are solving for the sum x plus y. Now, having seen these two methods, which method do you prefer? You can write that in our comment section. So thank you very much, and we hope to see you again in our next video. Bye for now.